You've now had some time to practice measuring and calculating pH in the PhET activity and the POGIL activity that you've done in class. This is a little review on calculating pH. Remember that the P in pH stands for negative log. So pH is just the negative log of the hydronium concentration. It's written here as H+. We could write that as H3O+. We use the two interchangeably. So for a solution with a hydronium concentration of 1 times 10 to the minus third, knowing our log relationships, the pH is negative log of 1 times 10 to the minus third, or negative 3, or 3. So the pH of this solution is 3. Since pH is a log scale based on 10, a pH change of 1 unit represents a power of 10 change in the H+ concentration. That is, a solution with a pH of 2 has a hydronium concentration 10 times higher than that of a solution with pH 3. So as the pH goes down, the hydronium concentration goes up. It's more acidic if it has a lower pH. One useful relationship is the expression Kw is equal to the hydronium concentration times the hydroxide concentration, and that equals 1 times 10 to the negative 14. Kw is the ion product constant for water. This means that if we know the hydroxide concentration, we can calculate the hydronium concentration, and vice versa. This is very useful in calculating the pH of bases, where it's often easier to find the hydroxide concentration than the hydronium concentration. We can also calculate the pOH of solution. So P means negative log. pOH is just the negative log of the hydroxide concentration. Using our knowledge of logs and the water equilibrium expression above, we can take the negative log of both sides of the above expression and see that negative log of H+ times OH- is equal to negative log of 1 times 10 to the minus 14. Once we do the math, we see that the pH plus the pOH equals 14. This expression makes it easier to calculate pH and pOH for acids and bases. There are 3 possible aqueous solution situations. If the hydrogen concentration is equal to the hydroxide concentration, then the solution is neutral and the pH is equal to 7. If the hydronium concentration is greater than the hydroxide concentration, then the solution is acidic and it has a pH that's less than 7. And if the hydronium concentration is less than the hydroxide concentration, then the solution is basic and the pH is greater than 7. Here's a chart that shows us some of the pHs of common things in our environment. So we see stomach acid has a very low pH at about 1.5. It's very acidic. Lemon juice is also very acidic. Cola, tomato juice, milk. Milk is it's slightly acidic, but it's getting close to pure water. And then we have things like blood, seawater, household ammonia, and these are all basic. Note here that normal rainwater is acidic. We're going to talk about that in the next learning module. There's also something that we call acid rain and acid fog, which is even more acidic than normal rain. There are several ways that we can measure pH, one of which is using a pH meter. We can also identify whether things are acidic or basic using litmus paper. So if a base is applied to red litmus paper, then it turns blue. If an acid is applied to blue litmus paper, then it turns red. This won't tell us the actual pH, but it will tell us if something's acidic or basic. A pH meter will tell us the actual pH.